Precalculus Lesson 25 continues with applications of linear equations. This is section 6.2 in the College Algebra textbook. Let's get started with an application. Alta High Marching Band is selling tickets to a chili dinner to raise funds for new uniforms. They sell 802 tickets for a total of $8,732. The tickets were priced at $15 for adults, $8 for children, and $10 for students. If there were 48 more adult tickets sold than student tickets, how many of each type of ticket were sold? So let's start by creating some variable names. Let's let A represent the number of adult tickets, C the number of child tickets, and S the number of student tickets. And then we'll need some equations. First of all, looking at the total number of tickets, 802, we can create the equation A plus C plus S equals 802, and then moving on to the total amount of money taken in, $8,732, and noting that adult tickets were $15, child tickets were $8, and student tickets were $10. We have 15A plus 8C plus 10S equals 8,732. Then finally, we need one more equation, and we note that there were 48 more adult tickets sold than student tickets. So we get the equation number of adult tickets equals the number of student tickets plus 48, or A minus S equals 48. Okay, let's move on to solving these three equations. And the first thing I'll do is give each equation a name. The first equation I'll call number 1, the second number 2, the third number 3, and then we need to determine which variable we want to eliminate first of all. And seeing that C is missing from equation 3, let's decide to eliminate C. We'll use equations 1 and 2 here. And noting that we'll need to multiply equation 1 by -8, so that when we add equations 1 and 2, we will eliminate the variable C. And so equation 1 becomes -8A minus 8C minus 8S equals -6,416. I add that to equation 2, 15A plus 8C plus 10S equals 8,732 to get 7A plus 2S equals 2,316. which I will refer to as equation 4. And now we need to look at equation 3, compare it with equation 4, and if I want to eliminate the variable S here, I note that equation 3, I'll need to multiply by 2 so that the S terms add to 0. So let's take 2 times equation 3. That would give us 2A minus 2S equals 96. We add that to equation 4. 7A plus 2S equals 2,316 to get 9A equals 2,412. Solving for A gives us A equals 268. So we found the number of adult tickets that were sold. From there, we can back substitute into equations used previously to find the number of tickets sold to children and the number of tickets sold to students. Okay, so let's go back and let's grab equation 3, I guess. So using equation 3 here, we're going to plug in 268 for A. We have 268 minus S equals 48. That tells me that negative S is going to equal -220, or S would equal 220. So 220 student tickets were sold. And then we move on to either equation 1, 2, or 3. Let's just grab equation 1 here. And for equation 1, I can plug in A equals 268. C, we are trying to find S equals 220, and that equation equals 802 on the right side. So we can add 268 plus 220 to get 488, and then subtract 488 from each side. We have C equals 314. So there were 314 tickets sold for children's entrance into the chili dinner. And let's move on to a different type of problem here. So for this application, we're going to find the quadratic function passing through the points 2, 3, -4, 39, and 5, 12. So if you think of the parabola that's going to be passing through these 3 points, what would the equation of that function be that represents the parabola? Okay, so the first thing I'm going to do is note that a quadratic function is of the form f of x equals ax squared plus bx plus c. If I can figure out what a, b, and c are here, I've got it. Okay, well, let's take our first point that we're given that's on the curve, the point 2, 3, where x would equal 2 and y would equal 3. We're going to plug in 3 for y, and we're going to plug in 2 for x into f of x equals ax squared plus bx plus c, and then we simplify to get 4a plus 2b plus c equals 3. We'll do the same thing with the point -4, 39. We'll plug in 39 for y, we'll plug in -4 for x, and we end up with 16a minus 4b plus c equals 39. And then finally, we'll take the point 5, 12, where x is 5, y is 12. We get 12 equals a times 5 squared plus b times 5 plus c. Simplify to get 25a plus 5b plus c equals 12. And let's move on to solving this new system of equations, where equation 1 is 4a plus 2b plus c equals 3. Equation 2 is 16a minus 4b plus c equals 39. And equation 3 is 25a plus 5b plus c equals 12. Okay, so I'm going to decide what variable to eliminate here, and let's go with c. And so to eliminate c, I'm going to choose equation 1, equations 1 and 2, and then the other pair of equations I'll choose is equations 1 and 3. So we can go ahead and write equation 1 down. Note that for equation 2 and 3, to eliminate c in each of those, I'm going to need to multiply the equation by -1. And so we have -1 times equation 2 is equal to -16a plus 4b minus c equals -39. -1 times equation 3 would be -25a minus 5b minus c equals -12. We add these equations together, resulting in, first of all, -12a plus 6b equals -36, and we'll call that equation 4. And then adding equation 1 to the negative of equation 3, we get -21a minus 3b equals -9, and that will be our equation 5. Okay, so let's move on. And from equations 4 and 5, I'm going to choose to eliminate b next. And so I'll need to multiply equation 5 by 2, so that when I add these equations together, the b terms add to 0. So we have equation 4, which is -12a plus 6b equals -36. And then I have 2 times equation 5, which would be -42a minus 6b equals -18. Adding these together gives us -54a equals -54, or a equals 1. Okay, so we found A, and let's move on to see if we can figure out B and C. So I'll start here by rewriting the 5 equations we have so far, and then to solve for, let's do B next. I guess to solve for B, we could use either equation 4 or 5. I'll use equation 5 here. And remembering that a equals 1, using equation 5, we would have -21 times 1 minus 3b equals -9. And then we'll go ahead and add 21 to each side, giving us -3b equals 12, or b equals -4. So we have a, we have b. We can now use any of our first 3 equations to solve for c. Let's go ahead and just use equation 1. And substituting a equals 1 and b equals -4, we have 4 times 1 plus 2 times -4 plus c equals 3. We simplify to get -4 plus c equals 3, or c equals 7. Okay, so at this point we've solved for a, b, and c. What do we do with these numbers that we found here? Well, we're trying to find the quadratic function where we have f of x equals ax squared plus bx plus c. We know that a equals 1, b equals -4, and c equals 7. We just plug in those numbers into our function, and we end up with f of x equals x squared minus 4x plus 7. Try on your own number 2. Find the quadratic function passing through the points -1, -4, -3, 2, and 4, 51.